So now I'd like to talk about working with percentages. So we have a couple examples here. In a Harris Interactive survey of 514 human resource professionals, 90% said that the appearance of a job application is very important for a good impression. Now, that's a percentage. What if I wanted to know the exact amount of people who responded and thought that appearance was really important? What I would do is I would take this 90% and convert it to a decimal. So I'd take 0.90 times 514, and I get 462.6. The problem is you can't have 462.6 people, right? So what I want you to do is round up. Even if the decimal's below a 0.5, always round up. So I'm going to say that there were 467 people who said the appearance of a job applicant is very important for a good first impression. This next question says that of the 514 surveyed, 100 said the appearance of a job applicant is not important for a good impression. Okay? So what percentage of respondents was this? We're going to go ahead and take 100 divided by 514, and we're going to get 0.1945. So I would round that to 19.5%. I wouldn't recommend going more than one decimal place out. This is still very precise. So let's talk briefly about some critical thinking skills. And what I want us to talk about is, when should you believe a statistical study? So in order to know whether or not you can believe a statistical study, the first thing you need to do is just get a big picture view of the study. What is the study's goals? What's the population? Did they clearly define the population? Remember, you don't just want to study students. You need to narrow it down more than that. You also need to determine if your study was observational, experimental, or a meta-analysis. This is when you review existing research. Consider the consider the source. Who is funding the study, right? Studies can be expensive, they can be time consuming, you have to get a lot of participants. And if, say, Coca-Cola was trying to do a study on the fact that Coca-Cola didn't cause people to gain weight, right? That would introduce some bias, so we have to be really careful. Another thing we need to know is, do they share how the study was conducted? Something we really need with any study is we need it to be repeatable and hopefully get very similar, if not the same, answers. And in order to do that, the study must share how they conducted their study. Peer review is a process in which, after the study is completed, several experts evaluate the research report before it's published. I would recommend, when you're doing research for research papers and things like other courses, always make sure that the articles you select are peer-reviewed. Next, we want to look for bias in the sample, and there's several different types of bias. Okay. One is selection bias. Okay, this occurs whenever the sample is selected in a biased way. So, for example, convenient sampling is one way to do it in a biased way, or sometimes cluster sampling, as we talked about, can introduce bias. Another one is participation bias. So this occurs anytime participation in a study is voluntary, asking for volunteers. People typically only participate in studies they want to believe in, and they want to share their opinion. The last one is a self-selected survey. So this is a voluntary response survey. Okay, this can introduce bias because it's one where people decide for themselves whether or not they want to be included in the survey. I'm sure you get a couple of these via email every semester. And this self-selected survey, this is the most common form of bias because those who feel more strongly about an issue are more likely to participate. If you're just like, I don't care about the food in the cafeteria, you really aren't going to participate in a survey about the quality of food in the cafeteria. So here's an example. Okay. So the television show Nightline conducted a poll in which viewers were asked whether the United States headquarters should be kept in the United States. Viewers could respond to the poll by paying 50 cents to call a phone number with their opinions. The poll drew 186 responses. 67% favored moving the United Nations out of the United States. Around the same time, we conducted a poll using a simple random sample of 500 people, and found out that 72% of the United Nations, 70% of people wanted the United Nations to stay in the United States. Which poll is more representative of the general opinions of Americans? So even though our simple random sample poll had a much smaller sample size, this was randomly generated, okay? The one for the TV show got way more respondents, but they had to not only self-volunteer and take the time to call, they had to pay. So you're only going to pay the 50 cents if you have really, really strong opinions. So our most representative poll would have been the smaller poll that used simple random sampling. Next, we want to look for problems in defining or measuring the variable of interest. Okay? Results of statistical studies can be difficult to understand if variables are difficult to define or measure. Okay? One of my favorite instances of this is in mascara commercials. They'll say, oh, this mascara gives your eyelashes 40% more impact. Well, how do you measure the impact of an eyelash? You'd have to have that really well defined, and you could. You can try and define things like that, things that are so qualitative, but you have to do it well. So, for example, a commonly quoted statistic is that law enforcement authorities succeed in stopping only about 10 to 20% of the illegal drugs entering the United States. Should you believe this statistic, and why? Well, you should probably not believe this statistic, right? Because how do we know how much is getting in? They only know how much they're stopping. So what they're doing is presuming and making a false assumption of how many drugs are getting in the United States. So I would definitely not believe this statistic. Next, you want to be aware of confounding variables. Okay? Often variables that are not intended to be part of a study can make it difficult to interpret the results properly. One example of this is confounding variables. My favorite example is that as ice cream sales increase, so do the number of children with broken arms. Right? And you might think that there's some kind of relationship here, but there's a confounding variable, and that confounding variable in our case between ice cream sales and broken arms, because more kids are outside playing outside and it's hotter, so more people are buying ice cream, our confounding variable is the time of year. It's the fact that it's summer. Next, you need to consider the wording in surveys. Even if you don't mean to, your wording can introduce bias. Okay, so you have to make sure that you clearly define your terms and you don't use any negative or positive leaning verbiage. So, for example, do you want a tax cut? The Republican National Committee conducted a poll to ask whether Americans supported tax cuts. And when people were asked, do you favor a tax cut? A large majority of respondents said yes. Okay? And I don't blame them. If someone was like, do you want to pay less taxes? I'd be like, yes. But should we include that Americans supported the proposal? No. Right? If you take a tax cut, that means they're cutting their income, and so more might have to come out of your pocket. Like, okay, well, we're going to give everybody a tax cut, but we're going to start charging more for property tax. Or we're going to have to start charging you to attend public schools. Or we're going to decrease our funding to the arts. Those are things you need to look at in a proposal, not just whether or not you want a tax cut. So we should not conclude that Americans supported this proposal. Next, you need to check that the results are presented fairly, okay? When a statistical survey is well done, it can still be misrepresentative in graphics or concluding statements. So be sure to look at your scaling on the X and Y axis. So here's an example. What makes the graph on the left misleading compared to the one on the right? So what makes the graph on the left misleading is it starts at 150K. It doesn't start at 0 like the graph on the right. So therefore it seems like this company made very little money and these other companies did so much better, when in reality they did a pretty good job. I'd be happy to make 163K in sales if I was in sales, right? So this is very misleading because they messed with the scaling of our y-axis. Next, you need to stand back and consider the conclusions. Did the study achieve its goals? Does the conclusions they came to make sense for the data they collected? Could we rule out alternative explanations for the results, like confounding variables, bias, things like that? And if the conclusions make sense, do they have any practical significance? There are studies out there that don't appear to have any practical significance. Okay, like studies that study, the speed of frogs' tongues getting flies and stuff like that. That doesn't really have, a ton of significance for me. So make sure when you're designing a study that you will add to the literature and improve the knowledge around your field of study. So let's take a quick quiz. The collection of all cars registered in the United States is an example of a population. Is that true or false? Well, I think that's true. Selecting every fifth name on a list results in a simple random sample. No, that would be false. If we're selecting every fifth name, that would be a systematic sample. The average age of people who respond to a survey is a parameter. Remember, parameter refers to a population. So this is going to be a statistic. So false. Eye color is an example of ordinal data. Ordinal means it has an order. Is there a hierarchy of eye color? No, so this is false. If we wanted to correct this sentence, we would say eye color is an example of nominal data. Are the weights of motorcycles discrete or continuous data? Friendly reminder, discrete data can only take on set values. Continuous data can take on any values in an interval. It's typically something that you measure. So because we're weighing the motorcycles, this is going to be continuous data. For a study in which subjects are treated with a new drug and then observed, is this study observational or an experiment? Remember, observational studies don't have any treatment. Experimental studies do. So because we're treating our subjects with a new drug, this is an experiment. So our movie ratings of G, PG, PG-13, and R, qualitative or quantitative data? Well, they don't have a number associated with them, so they're qualitative. So if they're qualitative, what level of measurement are they? Well, there are two levels of measurements for qualitative data: nominal and ordinal. Now, movie ratings have a specific set order, so this is going to be ordinal level of measurement.